Hello ENS201 students. ان شاء الله ما نكون زهقانين بالبيت وعم تستفيدوا من وقتكم، اكيد لتدرسوا وكمان لترتاحوا وكمان لتدافعوا عن قضية وطننا. اليوم فكرت انه بسجل chapter one of the chapters that we already missed، وخلينا نشوف اذا هيدي الطريقة منيحة وبتقدروا انتوا تتابعوني. برجع بعمل انا the two other chapters that are missed، وبنفتح discussion board على البلاك بورد، discussion forum، والاسئله اللي عندكم اياها بتبعتوا لي اياها وبنتحاور، وبس ارجع بنعمل practice quiz وبشوف وين عندكم gaps. I highlight the gaps, we discuss them in the class. okay. هيدا will save us makeup sessions وكمان will fill in currently your free time. So before I start, just let me make a small note انه انا قاعدة بالبيت so I might have some pauses، بس will do my best to make it clear simple. Please let us communicate. Okay, I will get started. This chapter is about air, weather, climate. It's a very interesting topic, especially that we are all concerned, we all need the air, and we will deal about the gases that are present in the atmosphere and the different layers. So in the atmosphere, what is the composition, what are the different layers, the structure. We will talk about greenhouse effect and greenhouse gases. I guess you already heard about greenhouse gases. So what are the major gases and what is the effect of each gas on the environment. Then we will, at the end of the chapter, we talk about current evidence of climate change. We will give examples, and the last point will be about winners and losers. So are you ready? Let's get started. Do you know what is the difference between weather and climate? So when we talk on a daily basis, today the weather is nice, there is a possibility of 30% precipitation, then this is weather, because we are talking about a short term in a specific region or a local region. However, when we extend, we talk about a long term period of weather. Let's say the forecast for a long period, this is the climate, and it does not only include a particular region, but it spreads all over a large region. Now, what are characteristics of the weather? Definitely when we talk about short term, we are talking about precipitation, moisture, humidity. Sometimes we say it's cold, but it feels actually less or more. So this depends on the humidity and moisture, the pressure and the wind power. So on a daily basis, we can talk about these measurements. Weather and climate, they are primary determinants of a large ecosystem that we call biomes, and also would affect the vegetation, the flora and fauna. So the flora, the flowers, the vegetation, and the fauna, the type of animals, they are all dependent on the weather or the climate of a large biome. Example of a biome, the desert, the tundra that we will discuss at the poles, either at the Arctic or the Antarctic pole. Okay, so please, if you have any concern about this, just drop me a line on the discussion forum, and then we will try to communicate. So, have you ever wondered whether the atmosphere composition initially was quite different than the current atmosphere composition? Sure. You have wondered, and sure it was different. So the major gases in the early atmosphere were hydrogen and helium, and we know these are the gases present in the stars, in the sun. And with time, if you still remember when we discussed Home, the movie Home, with time we started to have other gases. So from volcanoes eruptions, for instance, we had CO2, sulfates, sulfur gases, and then with the appearance of the, if you still remember, the cyanobacteria and the bacteria that were capable of doing photosynthesis, we started to have traces of oxygen, and then with the appearance of plants we had more oxygen, but yet we had even other gases that were erupting and present in the atmosphere. And if you still remember that the atmosphere was quite devoid of high toxic amount of CO2 because of also anaerobic or not necessarily anaerobic, of microorganisms that were capable of trapping the CO2 from the atmosphere, lowering down the CO2 level, and then having more oxygen and more suitable for life. Now, what is the percentage of, let's say, oxygen in the atmosphere? What is the highest composition of gas in the atmosphere? Well, if you still remember, we have nitrogen with 78%, oxygen 21%, and CO2, traces of CO2 0.036%, and the other gases that we discussed, whether H2O droplets or vapor, a trace amount of other gases, sulfur, including sulfur, and greenhouse gases that we will discuss, these are actually traces. Now, where do we find these gases? In the entire atmosphere or in a particular layer? Well, actually, if we look at several layers of the atmosphere, we have 4 major layers, and these gases that I discussed are in the troposphere, which is the first layer that extends up to 15 kilometers, and at the top layer of this layer, we have the flights or the airplanes flying. Okay, so all the weather and all the gases occur in the troposphere. Now, the troposphere does not have a stable or constant altitude. It might vary. This depends on whether we are looking at the sphere from the pole or from the equator. So above the equator it can reach up to 12.5, but above the poles up to 8 kilometers. And also the composition of the gases, they are not constant. They highly vary from one area to another. This depends on the wind current, whether we are at the poles or at the equator. What else do we know about troposphere? The temperature, we know it varies based on the season and the location, the latitude and the altitude location. And if we go, we increase the altitude, we can reach up to minus 60 degrees, where we find the tropopause. So above the troposphere we have a tropopause, and this is the boundary between the first layer, the troposphere, and the second layer, which is the stratosphere. The stratosphere can extend up to 45 kilometers. It is very important because it contains the ozone layer. What is the ozone layer? It is a compact layer condensed with O3, which is the ozone. It extends from 17 to 26 kilometers. And the major role of the ozone layer is to block the entrance of the solar UV radiation. So more than 99% of the UV is blocked by the ozone. We will discuss in a while the ozone hole and how it is affecting our troposphere and the health of the ecosystem. Now, what about the gas composition? It's quite similar to the troposphere. However, we have water vapor fraction 1,000 times less and ozone 1,000 times more. Okay, so we have more ozone, and since it is O3, then we expect to have less oxygen, because O2 with O will give us an O3. There is no mixing of gases, there is no wind current, and as a result it is relatively calm in the stratosphere. We don't have wind, and the temperature is also stable at the beginning, but as we go up, we increase in the altitude, the temperature then will increase. Above the stratosphere we have as well the stratopause, so between the two layers we have a pause. Initially we had the tropopause, now we have the stratopause, then we go mesosphere, and the fourth layer is the thermosphere. Mesosphere, the minimum temperature is minus 80 degrees. We don't have gases, nothing happens here. And the last layer, which is the thermosphere, it extends up to 1,600 kilometers. Thermo, this means we have high temperature. Why? Because we are reaching the outer layer next to the near as if we are moving near the star, the sun. Gases are in ionized form, and the composition of the thermosphere then will spread and merge with the outer space. And as I mentioned, the outer space has a composition of hydrogen and helium, just as like the initial atmosphere where life originally occurred. Now, greenhouse effect. Before I go for a pause, this means so far we know the difference between weather and climate. We know the four major layers of the atmosphere, including the troposphere, the stratosphere, the mesosphere, and the thermosphere, and you have to know the composition of each of the layers. Fine, you'll get questions about these four layers, and I will post a practice quiz at the end of this chapter. Now, we will shift gears. We will talk about greenhouse effect and greenhouse gases and how they affect our ecosystem. Control and F9. Where is F9? Control Shift. Okay. Fine. Look who came in. My little princess. Say hi, Nai. Say hi.
Hi.
Nai, how's the weather today outside? Tell them.
Sunny, but a little bit windy.
And windy. And what's the temperature? Around what? Around 20 degrees or 37? Are we in summer or almost winter, end of fall? How's it? Around 20 degrees?
Yes.
A bit windy. Thank you so much. So Nai is around and she's helping mom. So we continue with the greenhouse effect. What is greenhouse effect? Well, I'm pretty sure that every one of you has seen a greenhouse for agriculture. What's the concept behind it? Well, we need solar energy. When the solar energy hits the greenhouse, we have heat that is trapped inside the greenhouse, and this will create warmth, and as a result will help the vegetation. Somehow, similar effect takes place in the troposphere, whereby the solar energy that hits the earth is trapped within the troposphere by gases, and this will eventually increase the temperature and we feel warmer. Now, the solar energy, when it traps the earth, only third, 1/3 of the energy will be reflected back, and 2/3 will be actually absorbed by either the water or the land, and this will keep the land warm, will also help in fueling photosynthesis and generating wind. So if we have more energy that is being trapped and left in the troposphere, this means it is being trapped from moving up to the other layers and back to space, then we will have this radiation. Now, as concentration of the greenhouse gases rise, we will have emission more of infrared radiation, and this will also add heat to the lower atmosphere. Okay, so all depends on the sunlight that is hitting the planet Earth. What are the two major gases, greenhouse or green gases? So what do you think? What are the two major gases? No, it's not nitrogen, despite the fact it is 78% of the gas is nitrogen in the troposphere. Well, actually it's CO2 and H2O. These are the two major greenhouse gases. So water vapor and carbon dioxide. And the concentration would vary. We don't have a stable concentration, it varies, and also the length of time they stay in the atmosphere. Now here in figure 15.1, let us compare an ice shelf before and after this integration. We can see that it's more or less within less than a 1 month period. It's less than a month period. So February 23, March 2. And this is taken from the Antarctic Peninsula. And we can see that the ice shelf has disintegrated and almost collapsed in the ocean around 3,250 kilometers square. So, can we say this is due to greenhouse gases? For sure, and later on we will comment whether it has to do with the global warming and the global climate change. Now, also other gases we will discuss in a while have been highly increased in levels in the troposphere, and they are as well acting as heat gases, as trapping heat gases. Fine. So how do we know that global warming is taking place? Well, there is definitely current evidence and changes that are occurring that would ultimately tell us that global warming is taking place. Now, also data show that there is a close correlation between the level of CO2 that is increasing and the increase in the temperature. The species' time to adapt is also changing. So how they are adapting, we do have species extinction that we are witnessing. Other examples include high tidal level, high sea level, change in the pattern of the climate. So we do have changes. However, some environmental scientists would argue and would say this is natural, given the fact that we have passed through the little ice age and other environmental hazardous, not hazardous, but environmental period, eras where we had disasters on certain species, let's say dinosaurs, where they were extinct. So we did have a loss and a clash of fish species, other aquatic organisms that are not currently alive. And so the argument whether it is natural or human-made, which we refer to as anthropogenic, so this is a new term, please note it down, anthropogenic. Let me see if it appears here. Yes, in the first line, anthropogenic. So many scientists believe that it is anthropogenic. What do you think? Is it anthropogenic or is it natural? Okay, let's discuss this when we are back. And the earliest data on the change of CO2 comes from the observatory on the volcano Mauna Loa back in 1957, where we have data on CO2. What's the current CO2 level? Do you think it is changing, it is increasing? Well, please look at CO2 measurement currently, and also let's discuss this on the blackboard, whether the CO2 is increasing or stable. Okay, if you want, we can even discuss it on WhatsApp group, whatever you want, whatever you think is will enrich your knowledge and will enhance our communication. Let's have a look at this curve. On the x-axis, we can see the time period spanning 1958 to 2008 and above. On the y-axis, we have the carbon dioxide in parts per million, ppm, ranging between 310 to 390. And on the other y-axis, we have the temperature in degrees Celsius between minus 0.1 and plus 0.6. Now, the two curves we are looking at, we have in black the CO2 and in blue the temperature. Initially, let's look at the CO2. What do we notice? As if we have a consistent pattern of increase then decrease, and however, if we look at the slope, we have an increase. So one cannot argue that CO2 level is still the same as back in 1958. Definitely it is increasing. Is this correlated with the temperature increase? Sure. So there is a dependency between both. They are correlated. Why do you think we have this red up and down pattern for CO2? This is mainly due to the fact that we have seasonal changes of CO2 between summer and winter. In winter, the CO2 level will increase, in summer it decreases. Why? Because of photosynthesis. We have more trees in summer, more absorption of CO2, so it's gonna drop, and this pattern is consistent. So luckily we still have photosynthesis and it's still taking place. The temperature, it is increasing, not in a consistent manner, but we do have the significant increase. However, please spot the change in temperature. Is it a drastic change? No. So when we talk about the change in temperature, it can be in 0 point, and yet it is a change, and it is crucial for the effect of it on certain species, whether it's fish, animals, trees. So here we can see that the change is not yet high, but it's almost 0.7, because we reached minus 0.1 and then we are going up to 0.6. So almost the change is 0.7, and yet this is having a drastic effect on the life of the ecosystem. Fine. So the effect of global warming has been recorded from different countries and at different time periods. So let's say the sea level rise has been published to project up to 1 meter by 2100. So it is rising, and we might reach up to 1 meter. Why is this a concern? Because this might affect floods, might lead to floods, and this will affect New England, New York, Boston, all the cities that lie at sea level or near rivers. We might have as well heat waves. How do we know it is human caused? Well, definitely there are certain simulations that can be done, computer models, where they try to fit in a particular formula, in a particular measurement, only natural causes, and then they will try to see whether natural plus anthropogenic is doing an effect. And then they try to compare the projections and see where do we fit in currently, how is our current situation with the weather and the CO2 level. So based on the simulations and the models ran, let's say here we look at different continents. In blue we have the models that are only caused by natural forcings, and in pink we have both natural and anthropogenic. So again, anthropogenic, human made. And in black we see the observation of the temperature, of the current temperature, and definitely we notice that the black curve fits more into the pink model, which is both natural and anthropogenic. Okay, now we said CO2 and H2O are the mostly dominant greenhouse gases. However, we do have other gases that contribute, including methane. Methane, if you still remember, these are emissions from ruminants and rice paddies, so these are in agriculture, from anaerobic form of respiration, and these will be emitted and will absorb, will trap heat, mainly infrared. Nitrous oxide, it is emitted by vehicles, by agriculture, and let's say nylon production, fertilizers, because we know that nitrogen is rich in fertilizers for plants, so when they are present in the soil, they will dissolve with oxygen, they will form nitrous oxide, and these are as well greenhouse gases. They trap heat quite effectively. Now, contributors to global warming, we can see that China has the highest contribution, up to 24%, followed by the States. Then we have Western Europe, India, Russia, Japan, and other countries. So again, back to the point, if you still remember, when we talked about ecological footprint and how different continents and different countries use resources and how they are affecting their footprint on the planet Earth, we can see that mainly wealthy or developed countries like the States or China, since it's the primary producer of goods, currently they have the highest percentage of greenhouse gas emission, and they are the primary contributors to global warming. Why should I care? So yes, you would say, would you argue, why do I need to care? Why do I need to know about the climate change? Well, definitely we are all concerned, because if we continue with the high temperature, then this means the atmosphere is getting even warmer, and we can reach a place where we cannot go back. We cannot reset our changes. We can't go back to rescue species and rescue the health of our environment. Here they give us other examples of climate change, observation of average global temperature increase, as I mentioned already. We have the poles, they are warmer, we are losing ice shelves, the glaciers are melting, permafrost is melting, we have less polar bears, less penguins. So less polar bears because they are dying, Antarctic ice shelves are disappearing, penguins declined by 50%, alpine glaciers are retrieving. So you are not here responsible to memorize the numbers, but in general, if you are asked to give at least 2-3 examples of climate change, then you can say, well, an increase in the sea level, more floods, extinction of species in a rapid rate, decline in the penguin population or the polar bear population. These are all examples. Ice shelves melting. What else? Oceans are absorbing more CO2. Okay, and this is also damaging coral reefs. If you still remember the coral reef, the marjan, the coral reef in the sea or in the ocean, it is a hotspot for aquatic species. Now with the increase in temperature, there's an increase in water, and this is bleaching the corals. Why? Because the algae, they are migrating, they are not anymore living happily in their situation, in their environment, and as a result, corals are damaging. Droughts, we have more frequent droughts, and on the other hand, we have more frequent also floods in other countries. Okay. Other examples, storms are becoming stronger. So will it be expensive? Is the global warming a concern of even countries and politicians? For sure, because economically we will have lots of losses in order to substitute. We will have a lot of effect on the production of agriculture. The vegetation is being affected. So yes, it will affect our economy. Fine. Envisioning solutions. Back in 1997, there was the Kyoto Protocol, whereby major contributors in countries, representatives from the countries, they held a summit in Kyoto, and in order to discuss global warming, and they came up with a specific guideline on how to ban certain gases in order to reduce greenhouse effect. Now, interestingly, China and India were exempted. They didn't get in the agreement, and also Australia and US declined to ratify the agreement. So the other countries did ratify, but we know that the other countries, they are not the major contributors. And so by 2012, we did not reach the level set by the Kyoto Protocol. Currently, there are other summits. We are still debating about global climate change, and efforts are still being done, but we can even discuss this. Where are we? How far we have reached to ban or to stop the increase in temperature? This is a third point on our discussion agenda, and definitely we do have practices in order to help global warming or to halt global warming. Example, certain countries, they are retrieving CO2 from the atmosphere, storing it underground in reservoirs. So example, Norway will do this. We will have aquifer of CO2. This gas will then can be used in order to generate electricity. Not only carbon dioxide, but also methane can be trapped and reused as an energy, or a biogas as an energy source for electricity or for heating. There are certain fines and taxes that are being made. So example, how do we measure our water use? We can as well measure the emission of gases per country, and certain fines and taxes can be put on pressure by the countries in order to regulate their effect on global warming. Other alternatives would be to switch to renewable energy, and this will save us from emission of toxic gases and greenhouse gases. Denmark produces 20% of electricity from windmills. China is reducing, however, I'm not sure how efficient this is. Other countries like Copenhagen, Helsinki, Toronto, they have pledged to reduce the carbon dioxide by 20%. And other conservation efforts, they have been done. These are benefits. How far are we in Lebanon doing these efforts? How are we controlling our greenhouse gases emission? Well, this is an open question. We can discuss it as well, but it is of course of our concern in order to save our country and the planet Earth. Okay, these are other current evidence that you can have a look if we already mentioned them. So here, potential global temperature and precipitation change. Certain environmental scientists believe that we might have a mirror image of what's happening currently regarding temperature and climate, weather and climate. In yellow and orange, or beige and orange, we can see these countries that might suffer from increase in temperature, and we can see that the Sahara Desert and North Africa, they might have a higher or more precipitation, decrease in temperature versus the poles where we will have more increase in temperature or warmer and less precipitation. Winners and losers, then northern Canada, Siberia, Alaska might be actually winners because they will enjoy warmer temperature and longer growing season. South Asia, most of Africa also, they will have an increase in crop yield. And other countries like Antarctica, Greenland might melt, and this will actually lead to floods, and this is a disadvantage. Where do we stand? How are we behaving as in Lebanon, in the country? Well, definitely there are pros and cons. One cannot wait by simply opening a small debate. We need to read more, we need to open a debate and come up with a conclusion.